Vanakkam one and all. We will discuss problem number 1 of exercise 5.4. So in the exercise 5.4 we have expressions related to exponential function e power x. So derivative of, in theorem 5 it was given derivative of e power x as e power x. So the derivative of exponential function won't change. Now we will differentiate this function with respect to x. So let us take the given function as y. So y is in u by v form. So we have to apply u by v, quotient rule. In quotient rule, derivative of y will be v du minus u dv by v square. Here in the given problem, in place of u we have e power x, and in place of v we have sin x, and derivative of u with respect to x will be e power x, and derivative of v with respect to x will be cos x. Now we will apply these values over quotient rule to get the derivative of the function. So dy by dx equal to v du. So v is sin x, du is e power x minus u dv. U is e power x, dv is cos x divided by v square. V function is sin x. When we square it, we will get sin square x. Now it's a derivative. This expression can be written as dy by dx equal to e power x into sin x minus cos x by sin square x. This is the derivative of the given function with respect to x. Now the second problem we are given e power sin inverse x. Okay. So we will find the derivative of this function. Before that we will calculate the derivative of this inverse trigonometric function, this sin inverse x alone. So let us take w as sin inverse x, and the sin w will be x. When we differentiate this expression with respect to x, we will get 1 dy. Okay, when we differentiate this with respect to x, we will get 1, and this term will be cos w and dw by dx, and dw by dx will be 1 by cos w, and based on the identity cos square w plus sin square w equal to 1. So we will here in place of cos square, okay, in place of sin square w we can replace x square, 1 minus x square. So cos square w will be square root of 1 minus x square. So we can replace this expression over here. It is 1 by square root of 1 minus x square. Now derivative of the sin inverse function is 1 by square root of 1 minus x square. We will apply that over the given problem. So y is equal to e power sin inverse x. We will differentiate this dy. When we differentiate this with respect to x, we will get dy by dx equal to e to the power sin x. We are using chain rule. We will differentiate this function using chain rule because it is a composite function. So at first we have to assume the full function as e power x. Derivative of e power x will be with respect to x will be e power x. So we will get e to the power sin inverse x. Now we have to differentiate this d by dx of sin inverse x. Okay, that is what we have discussed here. So the derivative of sin inverse x is e power sin inverse x into 1 by square root of 1 minus x square. Yes, with this we are done with this problem. We have calculated derivative of the given function with respect to x, and it was a composite function too. Okay, now we will look at problem number 3. Now in problem number 3 we are given e to the power x cube we will differentiate this function with respect to x. We will get dy by dx equal to, again as per the definition of dy by, as per the definition we will get e to the power x cube, because the derivative of e power x remains same, and we will differentiate x cube now. So derivative of x cube will be 3x square. So this is the derivative of the given function with respect to x. Again here we have applied chain rule because it is a composite function. It is consisting exponential function and a polynomial function in it. So we have applied chain rule to get the derivative of the function with respect to x. Thank you.